Let's study chemistry together with CBSE Chemistry Tips and Tricks.
For the decomposition of azoisopropane to hexane and nitrogen at 543 Kelvin, the following data are obtained. You can see the data, right? Calculate the rate constant. Here, the only difficult task is writing the decomposition reaction of azoisopropane to hexane and nitrogen. That maybe you have to by heart. See, this is the reaction CH3 twice CHN double bond N, then same repetition of the LHS part CH, then CH3 twice. They undergo decomposition to give what? Hexane. What is hexane? That is easy, right? C6H14. Correct? H14 plus nitrogen N2. Okay. As it is an NCERT question, better by heart this decomposition reaction. If you check the table, you can see that it is a pressure related question. For time t is equal to 0, 360 and 720, see they have given the pressure. And you are supposed to find the rate constant. Now, hint number 1. If it is a pressure based numerical and you are supposed to find rate constant, understand the order of reaction must be first order reaction. Okay. Second hint. You have to check the stoichiometry of the reaction. If it is A gives B plus C, just like in the question. See, you check azoisopropane. Okay, what is the coefficient? 1. 1 azoisopropane gives 1 hexane and 1 nitrogen. A gives B plus C. A single reactant with coefficient 1 undergo decomposition to give 2 product and their coefficient is also 1. 1B and 1C. Then you can find the rate constant by using this equation 2.303 by T log P0 by 2P0 minus PT. Very important hint. Okay. So you can see in this particular question, see the stoichiometry follows this order, right? A gives B plus C. And understand it is a first order reaction. So you can directly use this equation for finding rate constant. Now, if you check the question, you can see when time t is equal to 0, pressure is 35 mmHg. That is P0 value. Okay, or P standard value. Now, at time t is equal to 360 second, you can see pressure. PT value is what? 54. And when time t is equal to 720, PT value is what? 63, which means you have 2 PT values. You have 2 cases, okay? So you have to find K for first case. We can say K1. For second case also you have to find K value. We can say K2. After finding K1 and K2, find the average of that. That will be the rate constant of the overall reaction. Okay, so we can find K1 first. K1. What is the equation? 2.303 by T. What is the T here? 360. Correct? Log P0 value is always what? 35 by 2 times 35 minus what is PT value? That is 54. Clear? On simplifying, you will get 2.303 by 360. You will get 0.0063 log 35 by 2 into 35 is 70. 70 minus 54, it is 16. Again, you can simplify like 0.0063 log 35 by 16. It is 2.18. Now, it will be like 0.0063 into log 2.18, you will be getting like 0.340. On calculating, you will get 2.175 into 10 raised to minus 3. What is the unit? Unit of rate constant of first order reaction is second inverse. So we got K1 value. That's it. Same way we can find K2, right? K2 is equal to 2.303 by What is the time? 720 log. See, P0 value is 35. It will never change by 2 times 35, right? 2PO. Minus, what is PT value? PT value is 63, right? 63. Correct. On simplifying, you will be getting like 0. See, on dividing this, you will get 0.003 log 35 by 2 into 35 is 70 minus 63. You will be getting like 7. So what is that? You will be getting like 0.003 log 5. Correct? 35 by 7 is 5. Log 5, you know, right? It is 0.6990. So 0.003 into log 5 value you have to by heart. Very, very important. 0.6990. And you will be getting like 2.235 into 10 raised to minus 3, right? Here, during finding K1, you can see log 2.18. 2.18 is the right. See, that value you have to find from the logbook. There is no other way. Okay. Now we have K1 and K2 for two cases. We are supposed to find the rate constant of the reaction, means find the average of K1 and K2. Okay. So K is equal to K1 plus K2 by 2. What is K1? K1 is 2.175 into 10 raised to minus 3 plus 2.235 into 10 raised to minus 3 by 2. And what is our final answer? Our final answer is 2.2 into 10 raised to minus 3. What is the unit of K for first order reaction? We know it, right? Second inverse. Hope all of you understand. Remember one thing, okay? If the reaction is of A gives B plus C, which means the stoichiometry of the reactant and both product is 1. And the question is related with a pressure related numerical. Then without thinking, you can go for which equation? You can go for this equation. No doubt in that, okay? But if the coefficients are different, then you cannot follow this method. So this is our final answer. Okay.